Yeah, so this question here comes from the Insight 2020 trial paper, so let's get stuck into it. So we've got this function down here where a is greater than 1 over this domain. The shaded region in the diagram below shows the area bounded by the graph of f and the tangent to the graph of f, which passes through the origin. So we've got the function there, we've got the tangent running off the function at this particular point here, going through the origin. Okay, the point P is the local maximum of f, and the point Q is the point of intersection of the graph of f and the tangent to the graph of f that passes through the origin. And so I'm just assuming that point Q is not going to be the turning point, but rather simply a point where the tangent goes through the origin. Okay, so this is just a basic tangent, not, well, it can't be the stationary point actually, because if it was the stationary point, tangent would look like that. So because it's not like that, it can't be at the stationary point. Right, so let's get stuck into it. Find the coordinates of P in terms of A. So to do that, what we'll do is we'll just define the function. Define f of x equals a times x, take 1, all squared, plus 1. Diff it, solve when it's equal to 0, and we get 2 points. Find the coordinates of P in terms of A, so it's probably this coordinate here. So that's assuming that this stationary point occurs at 1, and I can check this other point here. So what I'll do is I'll pop in a value of A larger than 1, like 2, into this second point, and what should happen is this value here that comes out when A is equal to 2 should be less than 1. Yeah, it's 2/3. And that should happen for all values here. So if I change it to 10, it should always be less than 1, meaning that this solution here is for this stationary point. So that's 2 over 3a plus 1/3, comma, whatever the y value is there. So let's note that down. 2 over 3a plus 1/3, comma, f of that. Run a simp on that. Okay, and let's just get the other coordinate of the stationary point. F of 1, that's, so that stationary point there is 1, 1, and that's that. Okay, find the x coordinate of Q in terms of A. Okay, so what we'll do is we'll get the equation we'll get the equation of the tangent from point, let's just make this point here point B for argument's sake. So we'll go B, comma, whatever it is. So what I'm going to do is run calculation line, tan line on it. The expression is f of x at point B. Right, now what that's going to do, this thing here is the equation of this line here. And so essentially, what else do I know? I know that this line here runs through the coordinate 0, 0. So here's what I'll do. I'm going to solve this ants, and I'm going to let the y coordinate equal 0. So essentially, I'm subbing in 0, 0 into this equation here, which is written in mx plus c form. So what I'm doing basically is going, this is going to equal 0, and I've got the gradient plus c. So it's going to be mx plus c. And so I'm going to solve when that is equal to 0 for b. Okay, and b is this value here, the x value, with x equals 0. So this one here is when y is equal to 0. This one here is lets x equal 0 and says, okay, solve me for b. Okay. Don't know why it doesn't work sometimes for me, but yeah, I just have to, like, if it won't do it for me, I have to recopy it and repose the question again. So we've got b is equal to 0. Okay, that's obviously not the one. It's this one over here. So the x coordinate is b is equal to 1 over 2a plus 1, or x, the x coordinate, the value of x or b at this point here is 1 over 2a plus 1. All right. Find the area of the shaded region in terms of A. All right, so that's why they got us to do this here, is this gives us one of the terminals, 1 over 2a plus 1. So essentially what I'll do to get the area under the curve is I'm going to do an integral. So yeah, let's build it up. So integral between 1 over 2a plus 1 and 0 f of x dx. Now what that does is that's going to give us all of this area here, all of this stuff under the curve. All right, and then what I'll do subsequent to that is remove this area here, which is basically an area of triangle, and it's got a base of 1 over 2a plus 1 and a height of, well, I'll just fire that into the function, but it'll be f of 1 over 2a plus 1. Right, so let's finish our equations. So what we'll do is full area under the curve, take away half times the base, which is 1 over 2a plus 1, times the height, which is going to be f of 1 over 2a plus 1. All right, so this is full area, take away area of triangle, and that will be the area of the shaded region in terms of A. So that's going to be area function A of A. Okay, let's see how we go. Okay, pretty ugly. Let's see what a simp does. That's good. That's I probably know I'm on the right track when that happens. Usually when you hit simp and nothing really happens, you know you get some 4-foot long equation or expression for the area. You probably know you're wrong, but this means I'm probably on the right track here. Right, so there is my area function. All right, find the value of A where A is greater than 1, for which the area of the shade region is the minimum. Okay, so basically what's going to happen is as we vary this value here, right, what will happen is the basic shape of this will change, and what we want to do is minimize this area here. So for which value of A where A is greater than 1 will the area be a minimum? So the best bet is to grab this function here, and what we'll do is we'll actually diff this function here, diff the area function. I'm going to go diff ans. Now it's important because my answer is in terms of A, that when I use the diff function, I can't just assume it knows that it's A, it actually assumes that it's X. So I need to say diff answer for the variable A. But there's my derivative. So my working out is going to be A dash A equals 0. And so let's do that. Solve the derivative equals 0 for a. A is equal to -1/2. A is equal to 3 on 2. But a is greater than 1. So a is equal to 3 on 2. So essentially, when it's 3 on 2, when this value here, a is 3 on 2, what that will do is minimize the area. All the other values of a will be bigger than that one there. Or if you're trying to make this area here as small as possible, that value of a will do it for you. All right, so let's see what else this question has to offer. All right, let g, so here's g, it's a different function. No, it's the same function. Chopped at a point b here, where a is greater than and equal to 1 now, and b, be the x-coordinate of p, where p is the local maximum of f. All right, so that's that same point again. So the local maximum is, because it's the same function, the local maximum occurs at, where did it occur? 2 over 3a plus 1/3. So that's that point there. So that's what b is equal to. Okay, the diagram below shows the graphs of g, g-1, and y equals x. So this is the original. This is the inverse function. The region denoted by a is bounded by the graph of g, the line y equals x, and x is equal to b. Okay, so yeah, so it's chopped by or bounded by those things there. The region denoted by b is bounded by g-1 and the x-axis and x equals c, where c is the maximum value in the domain of g-1, which is going to be whatever this value here is. Because when these, so this is going, that point there is the same as that point there. So this c value here is going to be the y value, because what happens is these swap around. So this x value here, when we swap x and y, this will become the y value, this will become the x value. So go grab the y again. So it is, I might just look at it on this. So c is equal to, so the x value here is a plus 2 all squared 4a take 1 over 27a squared, comma, whatever. Okay, so find the area of b in terms of a. So we want this area here. All right, these problems here tend not to require you to actually get the inverse function itself, but rather just use the original function. So here's the plan of attack. This area here, so if you imagine this area here, if I pick that up and slotted it in here, it's the exact same shape. All right, so here's the strategy. What I'm going to do, I don't know whether this is the only way to do this, but this is a way of doing it, is I'm going to find the area from b over to 0. So let's do that. Integral 2 over 3a plus 1/3 and 0. This is g of x dx. Now, what that's going to do is that's going to give us this area here. All right, now, what we'll do then is we'll also then get the area of this, which is a rectangle, and then I want to remove this. Okay, so probably the simplest way to do it, now that I've already written this instruction down is to say that's negative. So I'm going to make this amount negative and add that to the area of this rectangle here. So that's going to be 2 over 3a plus 1/3. That's this value multiplied by this value here, but I'm just going to write that as f of 2 over 3a plus 1/3. Okay, so it's going to be area under the curve negated, so that's negative, plus the full rectangle, and what that will do is just end up leaving us with this part left over. If I had a thought about it better, I would have done area of rectangle, subtract this, but it doesn't matter really which order you do it in. Right, so that's the area in terms, that's going to give us the area of B in terms of A. Okay, so these usually take just as long to type into the calculator as I do work out what the hell is going on with the question. So got negative 2 over 3a plus 1/3, 0, g of x dx, add to brackets. I don't really know whether brackets are necessary here, but I'm just going to do them anyway. 2 over 3a plus 1/3. So just again going to over bracket this just in case some of the order of ups change. So it's just, this is the length times the width for the rectangle. So that's that there multiplied by brackets f of that. Okay, so a bit of faffing about here, but hopefully this does it. Pretty ugly. Come on, simp. Geesh. I don't know. Yeah, obviously I've typed something wrong in there because there's an E in there. I wouldn't have a clue where that's come from. Let's see what I've done. 2 over 3a plus 1/3 to 0, negating the result for g of x. I think I just use g and f of x is still the function. So I've obviously got a g of x function defined somewhere here. That's a completely different function. So moral of the story is this is g of x, but g of x is actually still the same function as the original. I defined it as f of x. So yeah, I mean, lucky I didn't go ahead and start to write that down because obviously that is not the answer. Let's just double check that. So my original function is f of x. So let's try that again for f of x dx. I wrote f of x there, so no wonder it's getting confused. Okay, here we go. It's another go. All right, that looks better. Okay, so a equals a plus 2 cubed, 5a take 2, all over 3 to 4a cubed. Okay, so I know that the area of that is this amount here. That's what that gives us. Find the value of A such that the areas of A and B are equal. So this area here matches this area here with A kind of, being the thing, or in this, the parameter A just varying the amount of gray space here. So what value of A is going to make this the same as this? So essentially what we'll do is we'll equate the areas. So I'm going to say that this A plus 2 cubed 5a take 2 all over 324a cubed is equal to, what I want to do is find the area of this, which is essentially going to be integral between b and 0, which is integral 2 over 3a plus 1/3, 0. And we're going to go f of x, take away x dx. So what that's going to do is we're going to get the area under there and then have take x to kind of chop out this part here. All right, just noticed here I'm mixing my functions here. This will actually still work even though I've got g of x here and f of the value there. We probably should stay consistent with the question that we're doing. All right, so this is the function g and g inverse. So I actually should use g on both of them, even though using f will be perfectly sufficient because f is the correct function, or the function that this thing is based on. So we're going to go g anyway. And let's just call this one g as well. Okay, so what we'll do is we'll run this through the calculator doing a solve for a, and we should get our value of a. Let's see what happens. So we're going to go solve. This thing here equals the integral between 2 over 3a plus 1/3, 0, f of x, take x dx. And what we're going to do is solve that for a. Okay. A equals -2, a equals 1. But what's a defined as? Greater than or equal to 0? Yep, there it is. But a greater than or equal to 1, therefore a must be 1, because -2 then doesn't fall within that domain. Yeah, pretty tough finish on the problem, but not too bad to that point there. Right, hope that helps. Good luck with that.